Hi, this is Automatic Gaming, and today I will show you an artificial intelligence which plays SuperTux. The artificial intelligence is hereby represented by a neural network, which has learned this all by itself and didn't rely on information from a playing human. But let's start from the beginning. First of all, SuperTux is a free, open-source 2D platformer game inspired by classic titles like Super Mario. Players control Tux, the Linux penguin mascot, as he embarks on an adventure through icy landscapes and vibrant worlds to rescue his beloved Penny. So let's help him with that. What you now see is the result of an approximately 12 hours training run, during which a neural network is trained using a reinforcement learning algorithm called Double Deep Q Network, short DDQN. In this method, an agent learns optimal policies by predicting Q values for every action, which it is able to use. The action with the highest predicted Q value will be chosen. But let's look into more detail. First, the neural network receives a smaller version of the game image. The pixels of this image are now fed into the first input of the network. Additionally, the network receives some state information of Tux in the second input, such that it not only sees the picture, but also knows where the penguin is heading. For example, the speed in horizontal or vertical direction. Now the neural network calculates its prediction based on this information and the parameters of the different neurons. The result is the Q value for every action. The actions in SuperTux, which are defined to be used by the neural network, are jumping left, right, down, and last, but not least, doing nothing. After the prediction, the action with the highest Q value is chosen and fed into the game environment. As the neural network and SuperTux run in different threads, the game is not waiting for the neural network until it is done with its calculation. Therefore, the network doesn't capture every picture, and depending on minor changes in system performance during every run, the input can vary a little bit, even if the same actions are conducted. This is also the reason why the shown video sometimes runs a little bit faster or slower. As mentioned before, reinforcement learning doesn't rely on a human to learn playing. However, it still needs to receive information, what is good and what is bad during the interactions of the agent with the environment. This is done by defining rewards for every chosen action. The first reward, which it receives, is positive when moving to the right in the intended direction of the level. Vice versa, he gets a similar negative reward when moving backwards. This motivates Tux to walk to the right direction. Additionally, to keep him from aiming at the wrong end of the game, there are minus points if he dies by getting hit by an enemy. On the other side, he gets bonus points when he reaches the goal. Now Tux should be motivated enough to target the finished posts of the level. Before starting the training, and also sometimes throughout the process when reaching new situations, the predictions of a neural network are still pretty unreliable. In this case, the penguin is instead controlled by random actions, such that the agent learns to know the reward within the given situation instead of getting stuck. Unfortunately, our little penguin is trapped in a time warp until he learns how to reach the end of the level. This is necessary because when he dies or is somehow stuck in a situation, he can start all over again and learn new information in the next run. The consecutive runs are called episodes, as it can prolong the learning process when Tux always needs to start at the beginning of the level, even if he has specific problems with a later part of the level. We help him a little bit. If we can reliably say that he has mastered the way to specific points of the level, we let him randomly start from one of the defined checkpoints, which lie on the way. However, the level is only counted as completed when the agent is able to complete it all the way from the start to the goal posts at the end of the level. Together with the episodes, some progress information of the training is plotted. First of all, the accumulated reward of every episode and its mean value as well. The further Tux gets, the higher these values are. The second plot shows the number of saved memory. Due to memory limitations, this shouldn't become too big. Lastly, the loss is plotted, which is a numerical metric to describe the difference between the predictions and the true values. Since reinforcement learning has a different learning concept compared to supervised learning, for example, and also the memory is constantly changing, the loss is not continuously falling downwards. However, this is not a sign of poor training. But now let's observe how the agent is performing on SuperTux over time. As mentioned before, the agent initially is just doing random actions. Therefore, even when he's making progress, it is just a coincidence from the random action selection. Nonetheless, due to the continuous different actions, the agent is able to fill his memory and to increase the pool size, from which he can sample different combinations of state, action, and reward to use during training. Therefore, the neural network has already learned after a short time that it brings positive rewards if the penguin walks to the right. The next thing that happens more and more often is that the penguin jumps when running towards an opponent. This is because the agent received negative rewards when touching the opponent and the subsequent death of the penguin. Due to the random actions when reaching the opponent, the neural network has learned that it brings higher rewards if the penguin jumps over or onto the opponent. After a while, it's completely normal for Pingu to run to the right, jump over the first enemies, and reach a landing that he doesn't know yet. At this spot, the neural network learns over time that there is no point in pressing further to the right when standing in front of the step, and at some point it combines the buttons in such a way that it jumps up to the right to overcome the obstacle. As the agent now always reliably reaches the first checkpoint, he doesn't learn that many new things on the way there. As a result, the process now often starts directly from the first checkpoint, so that the neural network is confronted with the new paths more frequently. After the small obstacle comes a higher obstacle. In this case, the neural network also has to relearn that it is not just enough to jump briefly and press right, but that it has to predict jumping several times in succession so that the penguin gets high enough to overcome the obstacle. Once this obstacle has also been overcome, the penguin encounters 3 opponents at once. As he ends up with them differently each time, he has to learn different patterns to overcome them. After the wave of enemies, a new obstacle appears in the form of a pitfall. Above it are platforms that the penguin can use to jump up to the next landing. If he doesn't make it over the platforms first, he has to make sure that he jumps over the next ledge in time before the opponent falls on top of him. After a relatively easy stretch over a mountain, the penguin encounters another series of enemies, including a running bomb. As soon as the penguin jumps onto the bomb timer starts to run. As Pingu is used to running all the time anyway, it is very rare for him to stop and be hit by the explosion. Once he has also overcome these enemies, a section follows in which the agent encounters a familiar obstacle, the pitfall trap. Even if he had seen them before, there were several ways to overcome them. This time he has to time his running and jumping precisely so that the penguin jumps far enough to get over the pit. For this, he needs several attempts, especially for the second pit. In the next area, the penguin is surprised by a falling icicle. However, as he runs to the right all the time, it is relatively rare for him to be caught by it. There are also a relatively large number of bonuses in the following sections. However, the agent is not trained to achieve these. He only gets rewards for moving further to the right. Then comes a new tricky obstacle. An enemy with headgear hovers above a pit, which you can jump onto or over. Unfortunately, there are 2 more enemies running behind it, so you will need to use precise timing to get through this section. Once he has mastered that too, there's the last difficult obstacle before the finish. Unfortunately, our penguin can't read signs. At least I don't think the neural network has learned that yet. So he has to work out for himself that he needs a bit of a running start to get over the tall brown blocks. After a few attempts, where he gets stuck there for longer, he eventually learns it. After the last difficult obstacle, the penguin already has the finish line in sight. As soon as he has climbed the steps to the last mountain, a new opponent appears. At the top of the mountain, an opponent jumps up and down with a metal spring. Unfortunately, as he also has a metal hat with spikes on his head, the penguin can't jump on top of him, but has to run underneath. Here, too, it's all about the right timing. But after a while, the accidental action here also ensures that the penguin runs past him with ease. In the end, the penguin reaches the finish in one run from start to finish. The final run is also impressive. The trained neural network runs almost perfectly through the entire level in just about 1 minute. Even trained human players will take some time to achieve this. Thank you for watching this video. I hope you had fun looking at our small penguin running through the icy level and seeing the artificial intelligence learn how to handle different obstacles and enemies. If you liked the video, give me a thumbs up and then I'll be motivated to make more.